Hello everyone, welcome back. So this is our next video lecture and this is very important. Here we are now finally going to find out and learn about the method for finding square roots. The method using which we can find square roots. Actually there are a lot of methods by which you can find the square roots of some numbers. Let's see all of these. So first of all, let's begin that given to us is that finding the number with the known square is known as finding the square root. So first of all, what does finding square roots mean? So it means that finding the number with the known square, this is known as finding the square root. Finding the square root is the inverse operation of squaring. Yes. So finding square root is actually the inverse of squaring a number. Like 1 square equals to 1, 2 square equals to 4, we know all of these. 3 square equals to 9, 9 square equals to 81, and further minus 9, if you do the square of minus 9, then also you get 81. See here you get 9 square 81 and minus 9 square also 81. What's next given to us? We got to try these. It's written that 11 square is 121. Then what is the square root of 121? Just from the previous slide we saw that finding the square root is the inverse of squaring. So if the square of 11 is 121, then we can say that the square root is denoted by this. You can write here 2 also or directly this. Then we can say that the square root of 121 will be 11. Just the inverse of this thing. When we do square roots to both the sides like this will get cancelled because the power is 1 by 2. It will get cancelled and the answer comes to be 11. Now, similarly in this case, what is the square root of square root of 196? So, since 14 square is 196, therefore the square root of 196 is 14. The answer is 14. This is very simple, but now we'll see as we move further, we'll see some methods for finding the square roots. What's now given to us is minus 1 square is 1. Then is minus 1 a square root of 1? Or if minus 2 square is 2, then is minus 2 a square root of 4? And if minus 9 is the square of 81, is minus 9 a square root of 81? So these are the questions and you have to brainstorm about it, because since we know that finding square root is actually the inverse of squaring a number. So if we square minus 1, we get 1. Then is minus 1 a square root of 1? So actually, this thing gives us minus 1 and 1 both. Similarly, this can give us minus 2 and 2 both. Because even if we square minus 2 or if we square 2, we get the answer same as 4. Similarly, this can give us both these answers. Now square roots. Just see this, the statement and its inference. 1 square is 1, that is the square root or the under root of 1 equals to 1. Similarly, if 2's square is 4, then we can say that the square root of 4 equals to 2. So on, like 3 square is 9, then 9 square root is 3. And similarly, till we know that the square of 10 is 100, therefore we can conclude that the square root of 100 will be 10. Just the inverse of this. Finding square root through repeated subtraction. So first method that we have for finding the square roots of number is by repeated subtraction. Let's learn about it. What is given to us is the square root can be found out through repeated subtraction. So one of the methods by which we can find the square roots is through repeated subtraction. So what is the step 1 for this method? We subtract successive odd numbers starting from 1. So first of all, from the number we subtract 1, then from the resultant we subtract 3, then from the resultant we subtract 5 and so on. What is the second step? Second step is stop when you get 0. So we do this subtraction till we get the answer as 0. When we get our answer 0, we stop doing this method. What's at the last written here is that the number of steps to get 0 is the required square root. When we get 0, we stop doing this subtraction and then we just calculate, we just count the number of steps. We just count the number of steps, that how many steps were involved in getting the answer at last as 0. And the number of steps gives us the square root. The number of steps is the square root of that number. Let's do this and then it will be more clear to you. Now we need to find, in this example it's given that consider square root 81. This is the square root, that is we have to find the square root of 81. So the number given to us is 81. We are going to use the method repeated subtraction. First step is subtracting first of all 1, we get 80, then from the resultant subtract 3, we get 77. From 77 we are going to subtract 5, 72. From 72 we will subtract 7, we get 65. 65 minus 9, 56. From 56 subtract 11, you get 45. From 45 subtract 13, you get 32. From 32 now subtract 15 and you get 17, and at last you see that 17 minus 17 gives us 0. We have done our first step. First step included all these steps in it because we had to subtract the consecutive odd numbers. Now since we got 0 at the end, we are going to stop doing this subtraction, and the next step includes stopping here and then calculating the number of steps. The number of steps gives us the square root of this number. So just calculate how many steps are involved in this. 1, 2, 3, 4, 5, 6, 7, 8 and 9. So since there are 9 steps, we can say that I'll write this. This is what we had to find, that is the under root of 81. So the under root of 81 is equal to what? You can say 9. Why is that so? Because there were 9 steps. There were 9 steps in using this method of repeated subtraction till we got to the answer 0. So we can say that the square root of 81 is 9. This is how you use this method for finding square roots. And this method's name is repeated subtraction. Let's move now to the next slide. We have to try these parts. There are 5 parts given to us, and it's written that by repeated subtraction of odd numbers starting from 1, find whether the following numbers are perfect squares or not. So again we are going to use the same method, that is the repeated subtraction starting from 1, odd numbers. Now find whether these numbers that are given to us are perfect squares or not, and if the number is a perfect square, then we have to find its square root also. So first of all we need to find whether these numbers are perfect squares or not, and if these are perfect squares, then we got to find their square root. I'll do the first part. First part is 121. So our first step will include subtracting numbers. 121 minus 1 gives us 120. Further 120 minus 3 gives us 117. 117 minus 5 gives us 112. 112 minus 7 gives us 105. 105 minus 9 gives us 96. 96 minus, now what are we going to subtract from here? 11 gives us 85. 85, I'm doing the other steps here. 85 minus 13 gives us 72. 72 minus 15 gives us 57. 57 minus 17 gives us 40. 40 minus 19 gives us 21, and at last 21 minus 21 gives us 0. So first step is done. We are getting 0. Now we are going to stop here. After stopping, we are going to move to our second step, that is calculating the number, calculating the times, how many steps are included in at last getting our 0. So how many steps are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Since there are 11 steps included till we get to the answer 0, we can say that the square root of 121 is 11. This is what we have learned. This is the method of repeated subtraction for finding square roots. And yes, the first part was, is this number 121 a perfect square? So yes, this is a perfect square because from the properties of square numbers that I told you earlier in previous video lectures, if a number can be written as the sum of consecutive odd numbers, then that number is a perfect square. And we can easily see that 121 can actually be written as the sum of 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus, you can see 13, then 15, then 17, then 19, and then 21. It can be written as the sum of all these consecutive odd numbers. Therefore, this is a square number, and its square is the number of steps, that are 11. So its square root is 11. This is how you have to do this question. Now do all these 4 parts yourself. Again, start from subtracting from -1, then 3, then 5, then 7, 9, and so on till you get 0. And if you don't get 0, then you can easily say that the number given to us is not a perfect square. But if you get the answer 0, you can say that the number given to us is a perfect square, and the number of steps will give you the square root of that number. Solve all these questions, practice these as much as you can so that you get more clear about all these methods. Now, next method is finding square roots through prime factorization. So the second method that we have is the prime factorization. What happens in this method is, so in each prime factor in the prime factorization of the square of a number, it occurs twice the number of times it occurs in the prime factorization of the number itself. If this is not clear to you, I'll give an example. See, for an example, when you do the prime factorization of 6, what do you get? You get 2 into 3. And when you do the prime factorization of 36, you get 2 into 2 into 3 into 3. We know that 36 is actually the square of 6. And here also if you see, then since the prime factorization of 6 includes 1 times 2 and 1 times 3. But the prime factorization of the square of 6, that is of 36, includes 2 times 2 and 2 times 3. That is, the number gets doubled. The number gets doubled here, and this is what is written here in the statement, that each prime factor in the prime factorization of the square of a number, each prime factor in the prime factorization of the square of a number, it occurs twice the number of times it occurs in the prime factorization of the number itself. Since 2 occurs 2 times here, 3 occurs 3 times here, therefore in the square root of this number and the prime factorization of that square root, these are going to occur 1 times, because the number gets doubled, twice the number. Now find the square root of 324 by using this method, this new method, that is prime factorization. How we are going to begin? See, for the square root of 324, you can write, first of all, through prime factorization, our first step is going to be finding the prime factors. 324, 16, solve it. 9, 3, 3 and 1. So what is actually 324? What are the prime factors of 324? You can write 324 as 2 into 2 into 3 into 3 into how many times? 4 times 3. That is, you can write it as 2 square into 3 square into 3 square. Right? Pairing these numbers, 2 square into 3 square into 3 square, or you can write it as 2 into 3 into 3 whole square. This is exactly the same. That is 3 2s are 6, 6 3s are 18 square. Our 324 can be written as the square of 18. That is just the inverse of it. For the square root, we can say that the square root of 324 is therefore 18. This is what we had to find, and we found it out using the method of prime factorization. How do we start? We start finding the prime factors for it. We pair them up, and then we take it only one time for the square root. Because we are going to do this because of this statement. Now let's see this. It's given that is 48 a perfect square? So we know that 48 equals to 2 into 2 into 2 into 2 into 3, right? 4 times 2 multiplied by 3. But is then 48 a perfect square? What is written here is, since all the factors are not in pairs, so 48 is not a perfect square. Yes, right. 48's prime factorization goes as 2 into 2, 1 pair, 2 into 2, 1 pair. But 3, there is no other member for the pair of 3. We are not having one more 3 here, only one 3. So since all the factors are not in pairs, because 3 does not have any pair, so 48 is not a perfect square. So we can easily say that whether a number is a perfect square or not through prime factorization, if all the factors are in pairs for a number, then that number is a perfect square. But if all the factors are not in pairs, even if one of the factors is not in pair, then we will conclude that the number is not a perfect square. This is what exactly happened here. 3 does not have any pair here. So it's not a perfect square. Now we have a brainstorming question, and first question is find the smallest multiple of 48 that is a perfect square. In order to solve such questions, we are going to use the method of just the new method we learned, that is prime factorization. So 48 can be written as, we have it here 2, 4 times and then 3. That is 48 can be written as into 3. We have to find the smallest multiple of 48 that is a perfect square. So we know that 48 is not a perfect square because we don't have all the factors in pair. 3 does not have any pair. So in order to find the smallest multiple of 48 that is also a perfect square, so in order to find the smallest multiple of 48 that is a perfect square, we will multiply 48 with 3. Because if we multiply 48 by 3, we will get 3 here. That is, we get one more 3 here, and then this 3 will also be paired up. And all the factors are pairing up, therefore that number is a perfect square. And that is what we had to find. So 48 into 3, do it in your rough word. 144. And 144 can be written as since this is 48. Just a second. 144 can be written as 2 into 2 into 2 into 2 into 3, which was 48, and further 48 multiplying by 3, that is 3. You can now see that all the factors for 144 are in pairs. Therefore, 144 is a perfect square, and it is also a multiple of 48, and it is actually the smallest multiple of 48 that is perfect square. That is a perfect square. This is how you find such questions. For the second part, what's written? Can you tell by which number should we divide 48 to get a perfect square? Again, 48 equals to 2 into 2 into 2 into 2 into 3. Right? We are asked that what is that number by which when we divide 48, we get a perfect square. So, by which number should we divide 48 to get a perfect square? Since all these 2's are in pairs, but 3 is not in pair. 3 does not have any pair. So, what if we divide 48 by 3? Then 3 will get cancelled. 3 will go from here. When we divide 48 by 3, dividing it by 3, that is, this whole also gets divided by 3. So this will get cancelled, and what the answer we will be getting, that is, divide it, get 16. That will be equal to 2 into 2 into 2 into 2. This part, 3 gets divided. 48 divided by 3 gives us 16. And you can see for the factors of 16, all the factors are in pairs. Therefore, 16 is a perfect square, and it is the required perfect square. The answer is 16. We divided this number by, so the answer is dividing 48 by 3. Smallest multiple was 144. So these are the 2 more questions that can come up, and where we have to use this method of prime factorization. Finding the square root of 6400. Again, by the method of prime factorization, we are going to start it 6400, finding the square root of it. Again, when you solve it, you are going to get something like this. Again solve it, 400, again 200, then 100, then 50, and 25, 5, 5, and 1. So 6400 can be written as 2. How many times? 1, 2, 3, 4, 5, 6, 7, 8. 8 times 2. 4, 5, 6, 7 and 8. 8 times 2 and 2 times 5. So these are the factors of 6400. Pair them up. Write these only one time in order to find the square root of 6400. So for finding the square root of 6400, we will be writing all these pairs only one time. That is, we will write here 2, this as 2, this as 2, this as 2, and this as 5. Solve it and you get 80. So what is the square root of 6400? You can say that 80 is the square root of 6400. And how did you find it? You find it by using the method of prime factorization. This is how you proceed. This is your answer. Now we are asked, is 90 a perfect square? Again, by using which method? Prime factorization. We begin. Then 3, 15, 3, 5, 5, 1. We get, you can write 90 as 2 into 3 into 3 into 5. So for the square root of 90, you are going to write the pairs only one time. But when you find the pairs of these factors, you see that only 3 is there which has a pair. Neither 2 nor 5 are in pairs. Therefore, since all the factors of 90 are not in pairs, you can say that 90 is not a perfect square. 90 is not a perfect square. Why? Because its factors are not in pairs. All the factors are not in pairs. All the factors have to be in pairs for a number to be a perfect square. But here 3 is in pair but not 2 and 5. Therefore, it is not a perfect square. Now next question, that is example number 6 is 2352 a perfect square? If not, find the smallest multiple of 2352 which is a perfect square and find the square root of the new number as well. So is 2352 a perfect square? Again, do this. Use the method of prime factorization. 2 sevens are 22, 2 sevens are, 2 6 are, 2 5s are 10, 2 8s are 16, 2 8s are 16, 2 2s are 4, 9s are 4s are 2, just second 1, 7, 3, 9, and then we have 7, 7, 7 and 1. So we can write 2352 as how many times 2? 1, 2, 3, 4. 4 times 2, 1 times 3 and 2 times 7. Finding the pairs, pairing them up. Oh, see, there is no pair for 3. Therefore, this number is not a perfect square. Easily concluded. If not, find the smallest multiple of 2352 which is a perfect square. So just like the previous example, from the previous example we did that, for finding the smallest multiple of this number which is going to be a perfect square, we will multiply it by 3, because when we multiply this number by 3, we are going to get the pair of 3 as well again. So that number will be 2352 into 3. Find it out what that number is. 7056. So that number is going to be the smallest multiple of 2352 which is a perfect square is 7056. By multiplying this number 2352 by 3, we get this number. And we can easily see that 7056 is actually 2352 into 3. So 2352 can be written as this 2 into 2 into 7 into 7, and I'm writing 3 at the last. And again, if we multiply, this is 2352, this whole is 2352 by multiplying it with 3. Now pair them up. Yes, you're getting the pairs for all the factors, and then you can say that this number is a perfect square. And what is the square root? For finding the square root, I have told you, we'll be writing all these pairs only the members in these pairs only one time. That is this 2, this is 2, this is 7, this is 3. So 2 and 2, 4, 4 3 is 12, 12 7 is 84. So the square root of 7056 is actually 84. This is how you find it using this method of prime factorization. Next up is find the smallest number by which 9408 must be divided so that the quotient is a perfect square, and find the square root of the quotient. Again such question, again the use of prime factorization. 9408, 2, 2 4s are 8, 7 0 4 2. Just a second. And now it's 4 7 0 5, 6 5 2, 2 again, 7, and then 6 2, 8 8 2, and 4, and again 2 7. What do we have next? 3 4 9, and then 7 and 7, and just a second, where go? Here it will be 7, and then at last 1. So we can write 9408 as 2 how many times? 1 2 3 4 5 and 6 times 2. 3 4 5 and 6 times 2. 1 times 3 and 2 times 7. Pair them up. You get the pairs for all factor except 3. So again 3 for this number as well is not having any other 3 for it to be made into a pair. Therefore this number is not a square number. First of all, 9408 is not a square number. But we are asked that which is that smallest number by which 9408 must be divided so that the quotient is a perfect square. So since you can see that every other factor is having a member for its pair, every other factor is in a pair, but 3 is not in pair. Therefore, on dividing 9408 by 3, the number that you will get, that will be your smallest number, that is also a perfect square. That we get by dividing this number by 3. What is that answer? Divided by 3, you get 3. Now 3136. You get 3136. So 3136, find the smallest number by which this must be divided so that the quotient is a perfect square. So the quotient is coming to be 3136, and what is that smallest number by which we are dividing 9408 to get the quotient as a perfect square? That smallest number is 3. Now we need to find the square root of the quotient. So what is our quotient? 3136. So what will be the square root of 3136? Since we are dividing this by 3, so this whole gets also divided by 3. When it will get divided by 3, this 3 will get cancelled. So therefore, whole of this divided by 3, this will get cancelled. We are getting 3136. Therefore, 3136 can be written as 2. All those 2 just like it. 6 times 2 and 3 has got cancelled here. And then 2 7s. Pair them up. You get pair for each of these. And you can write therefore the square root of 3136 as 2 into 2 into 2 into 7. That is 2 2s are 4, 4 are 8, 8 7s are 56. Therefore the square root of 3136 is 56. What is the answer? The answer is 56. Again the same way. Find the smallest number, Find the smallest square number, not a smallest number but smallest square number which is divisible by each of these numbers. Which is divisible by each of these 3 numbers, that is 6, 9 and 15. This is our example number 8. This is quite a bit different from the other examples. We have to find the smallest square number which is divisible by each of these numbers. So first of all, let's just find a number, the smallest number I must say, that is divisible by each of these. So just the smallest number that is going to be divisible by each of these will be their LCM. Let's find the LCM for 6, 9 and 15. What is that going to be? It will be 2. Here we will get 3, 9 and 15. Now 3 we will get 1, 3 and 5. Again 3. We get 1, 1 and 5, and now 5 we get 1, 1. So what is the LCM? First of all, I am just finding the LCM, that is the least common multiple for 6, 9 and 15. What is the LCM for the same of 6, 9 and 15 is 2 into 3 into 3 into 5. That is what? You can see it is 90. The LCM for these numbers is 90. And 90 is written as 2 into 3 into 3 into 5. Pairing them up, yes, we get a pair for 3, but we are not getting, these 2 and 5 are not in pairs. And what we needed a smallest. We have found out the smallest number that is divisible by these 3 numbers. But this is not a square number. 90 is not a square number. We have to find the smallest square number which is divisible by all these 3. So for finding such a number, we are going to multiply this number by those factors that do not have any pair. That is 2 and 5. So if we multiply this number by 2 and 5, 2 and 5 will be get multiplied here also. I am writing 2 with 2 and 5 with 5. That is, it will become something like this. So the answer here is 900, and 900 will look like, its factors will look like this. Now you can see that every number, every factor is in pair. Therefore, 900 is the smallest square number which is divisible by each of 6, 9 and 15. And I'm doing an extra step that is not here needed, but the square root of 900 can be written as only one time. That is 30. The square root of 900 is 30. So this is the answer. Next up we have some other topic, that is number of digits in a square root. So how many digits will be there in the square root of a number? Now if a perfect square is of n digits, if a perfect square that is given to us has n digits, then its square root will have n by 2 digits if that n is even. And if that n is odd, then its square root will have how many digits? N plus 1 by 2. So if a perfect square is of n digits, its square root will have n by 2 digits if that n was even. But if that n was odd, then that number's square root will have n plus 1 by 2 digits. The number is 10, its square is 100, which is the smallest 3-digit perfect square. Yes, this is the 100 is actually the smallest 3-digit perfect square. So if anyone asks you that which is the smallest 3-digit perfect square, that is 100. Which is the greatest 3-digit perfect square? It is 361. That is the square of 31. This 100 is the square of 10, you know that. Which is the smallest 4-digit perfect square? It is 1024. That is the square of 32. And which is the greatest 4-digit perfect square? That is 9801. And it's a square of 99. So these are some facts related to some of the perfect squares. That is, the smallest 3-digit perfect square is 100, greatest 3-digit perfect square is 961, smallest 4-digit perfect square is 1024, and the greatest 4-digit perfect square is 9801. And this was the number of digits in a square root. If a perfect square is of n digits, its square root will have n by 2 digits. If that n was even and if that n was odd, then the square root will have n plus 1 by 2 digits. This is all about this video lecture. So what's the next topic that we are going to learn in the next video lecture? That will be finding square root by division method. So we have learned 2 methods for finding square roots in this video lecture, and in the next video we are going to learn about one more method for finding square root, and that method will be division method. We'll learn about it in the next video. Till then, bye bye, take care.